nonlinear. The first thing you're going to do on page 44, I need for you to write your essential question. How can linear and nonlinear be determined? And we're going to look at it on a graph. So we're going to look at the visual part of it. Linear should be a straight line, whether it's positive slope, whether it's a zero slope, whether it's a negative slope, and we're going to keep talking about this, or whether it's an undefined slope. It's still a straight line, so it's linear. We're also going to look at it from an equation standpoint. From an equation, it needs to look like y is equal to mx plus b. We're familiar with that one, where both my y has a exponent of just 1. That's why we don't write it. My x should have an exponent of 1. I could also write it as x is equal to 1. That would be linear. Y is equal to -2 would be linear. Okay, to give you a few examples. Y is equal to 3x plus 5. Those are all linear. So now I'm just looking at what linear isn't, and then we'll get into what it looks like when it's not. Okay? So to give you a few examples, this is what linear looks like. And I'm even writing my font with straight lines. These are all considered linear. Okay, the first thing you're going to do is take your foldable. And let's go ahead and start writing in it, and then we'll fold it up to look like what it should look like on page 44. So the first thing we need to do is look at what does it look like on a table. Well, we already know it should be a constant rate of change. What that means is when you see the 5 and the 11, and you're saying what does it have in common? What is the common difference? So it should have a common difference. So with the 5 and 11, I have a difference of 6, adding 6. 11 and 17, adding 6. 17 and 23, adding 6. Then I have to come back down here at the bottom and do the same thing. It has to be a same common difference with each interval of my x's. Now I'm going to check my y's. My y's, the common difference is plus 4, and plus 4. So as long as it has that common rate of change, or that constant rate of change. My x, I'm adding 6 is my rate of change. My change in x, my change in y has a common difference of 4. Let's look at the one below. The one below, my common difference, I can see very clearly as plus 1, plus 1, plus 1. With my change in my y, it has a common difference of 11, positive 11, positive 11, positive 11. So these are all the same, that's constant. These are all the same, that's constant. So I have a constant rate of change in each one of these. So that's what it should look like with a table that is done correctly, with a table that that shows linear function. All right, now I'm going over to the other side, which talks about nonlinear functions, because I want you to see the difference between the two. All right, with the table, The difference between the two and nonlinear, it will not show a constant rate of change. So let's take a look. I've got -1 to -2 to -3 to -4. Well, all of that so far looks like I am decreasing or subtracting by -1. So far, it looks like it's going to be constant, but I have to take a look at the other side, the y side, and I'm looking at the change. I go from 5 to 11. Well, that's a +6. Then I go from 11 to 24. That's a +10. And then when I look further, I'm going from 21 to 35. And as I can see, there's my 6, there's my 10. This is not a constant rate of change. It does not show a constant rate of change. Therefore, it is nonlinear. Now, the graph is a little bit easier to discover just because you're just looking whether the line is a straight line or a curvy line or a crooked line or a jagged line or a line that goes up and down. It's not consistent or it's not constant. Okay, so let's take a look over there. This is what it looks like a graph should look like if it's linear. If my graph is linear, the line will be straight. As you can see in both of these examples. In the graph example here with the grid, you can tell you have the constant rise over run being the same, almost like a staircase. Constant rate of change of being the same. Now let's take a look at the nonlinear functions. Nonlinear functions has a curvy line, or the graph will not be a straight line. Or if I have dots that don't appear linear, see how it rises up, positive, decreases negative, goes positive again, and then ends up with an undefined slope here. So even when I connect the dots, which I don't necessarily have to do, I can see this is not going to give me a consistent straight line. So this would be a nonlinear function. Okay? Now let's take a look at our equation, excuse me. Our equation for a linear, so I'm back on the other side with linear functions. Okay, an equation for linear, the variables may not, so be careful of this, they cannot contain or have exponents. And we'll look at some that are not. So if I have a y to the second power, an x to the second power, that's not going to be linear. Go ahead and rule that out. Okay, they may not be multiplied over each other, or multiplied to each other, excuse me. And I'll give you some examples of what that does not look like when we get over to the other side with nonlinear. Number 3, they may not be under a radical sign. So I'm just going to draw what a radical sign looks like. I cannot have this. So any equation that has a radical sign you're going to learn about that in math too, or an absolute value sign. So none of these funky signs should be in a linear function. And the last one, your x, they may not be your x or your y should not be in the denominator. And I'm going to give you those examples when they get to the other side. So the ones that we've been looking at here look like this. Now, I did mention that x is equal to, when it doesn't have a y, gives you a straight line. Let's say of 1. That gives you a straight line. However, this, as we know, gives us a vertical line. Which is linear, but it's not a function, as we learned earlier in that first unit. So be careful with this one. So it is linear, but it's not a function, so that's why it's not really listed here. All right, so I'm going to slide this over. And now we're going to look at equations that are non-linear functions. So your variables may contain exponents because they're non-linear, such as the example here. I can also give this example, y squared plus 1 is equal to x. Non-linear. They cannot be multiplied to each other. That's for linear. For non-linear, they can be multiplied. So if you see them written this way, as we're going to go through exercises together, they can, if it looks like 3 is equal to x times y. That's non-linear. The third one, they can be underneath a radical sign, such as this one. So they may have a radical sign or an absolute value sign, such as this one, the square root. And 4, they can be in the denominator. Such as this one, non-linear. So now what I'm going to do is I'm just going to fold this paper kind of in half. Not really in half, but I want to fold it over so that I still have my tabs showing. And then I'm going to take it and just fold it over in half.
Good morning, Bobcat. Today is Wednesday, October 17th, and it is an 8 a.m.
And write this on.